In this video, we'll discuss organizing files in your workflow. By the end of this video, you should understand how to organize files. I'm talking about scripts, data, and documentation in your workflow, and also steps that you can take to promote reproducibility with your file structure. So if you've seen in previous videos, managing complicated workflows requires organization. Organization of your computer files is an important component of that. I'm sure we've all seen someone else's computer that has a desktop that looks like this. Every file and link that you've ever seen is saved to the desktop in kind of a disorganized fashion. Keeping your files like this isn't just ugly. If you're trying to manage a workflow, it's going to hinder the transparency and reproducibility of that workflow. Importantly, it's going to waste a lot of time trying to find files and sorting out what you've done. So how should you organize your files to promote the core principles of data science? The first thing that you should do is use the tree-like structure of your computer folders to your advantage. You should use folders to separate projects from each other. Within those projects, scripts, data, and documentation from each other. And within your data, you should definitely use folders to separate your source and output data. And even further down, you may want to use folders to separate different versions of your data if you update your data over time, but you'd like to keep archival copies. So what would this file structure look like? Let's think about organizing files for your classes as an example. So everyone's computer has a documents folder, and inside of that you might have a folder for all of your classes. If you want to keep things organized, you don't want to think about classes that you've taken in the past, so you might have a folder for this semester, the fall semester. But you're probably taking more than one class, so you probably want subfolders within that semester folder for each class that you're taking, so you don't get files confused between classes. Your classes also probably make you do several different problem sets or have several different assignments. You want to keep those separate from each other as well, so you don't get components of those assignments confused or accidentally submit the wrong problem set. So in this example, under the AREC 380 folder, I have a problem sets folder and then subfolders for two separate problem sets. That would keep the problem sets separate from your project and separate from the other homework that you might have in the class. Now, the important thing to note here is that you've organized all of the content on your computer by what's contained in those files. So it's totally fine to have cat videos somewhere in your file structure. You just don't want them inside your AREC 380 folder. And so here I have the example of keeping your cat vids just as a subfolder of documents so they're easy to access, but at the same time separate from your coursework. You should take this kind of approach when organizing all of the components of your workflow. The tree structure and appropriate file names make it clear what's in each folder. It should also be obvious where the source data is for each problem set in the examples that I've given you, but more generally, when you're thinking about your workflow, it should be obvious where the source data are and where your results might be. The example that I gave you here used the documents folder on your computer. Companies will often have some kind of predefined file structure that sits on file servers that everyone shares. This isn't always the case, and so I really want you to think about the case if you're storing documents in the documents folder on your computer. Where is the documents folder on your computer? You don't think about it too much. You usually just click on the documents link, but it actually depends on what operating system your computer is using. So on Windows, your document folder is usually in Drive C in a subfolder called Users. Then there's a subfolder for each user with their username, and then finally a documents folder underneath that. On Macs and on Linux, it's actually in ~/documents. And that's because tilde is a shorthand for my home directory on Mac and Linux. That doesn't work in Windows though. Also, you should note that some Linux distributions don't even have a documents folder. The last complication that you'll run into here is you'll notice that on Macs and Linux, a / separates each directory name, whereas on Windows, it's a \. These are complications that make reproducibility more difficult. So even if you're keeping files organized in this structure, it still might pose challenges for reproducibility. And why is that? Suppose you want to give your script to someone else. This is what you should always be thinking about with reproducibility, is that someone else can reproduce your results by running your code from start to finish with your original data. Remember that your documents directory is in a folder that contains your username. So if you give your script to someone else, the path to their documents folder isn't the same as the path to your documents folder. What this means is, if they want the script to work, they're going to have to change the path to their home directory, to the directory, every time you reference a file. The same thing applies if you move your data. For example, if you change computers and change usernames, or decide you'd like to move things around on your computer. So what should you do to solve this problem? You should make it really easy for someone to update all their file paths. How can you do this? So remember that you can put anything in a variable in R, even the path to your documents folder. Or even more specifically, you can put something more specific than the path to your documents folder, like a very specific subfolder in your documents folder. What you should do is define this, do this at the top of your script, and then you'll reference that variable throughout the rest of your script instead of referencing your documents folder. The nice thing about this is you only need to change the path to your documents folder in one place in the script. So that's one change as opposed to every time a file is referenced. What's the best way to do this? R actually provides a function for dealing with file paths. It's called file.path. There is no tidyverse file_path version of this function. So this is one of the rare cases where you're going to be using a function with a dot in the name. And what it takes are folder or file names as arguments, and then it returns a string that is the path to that folder. So in the example that I have here, I'm referencing a directory on my computer where I have the C drive and then my username and then desktop. I put those in as arguments in file path, and you see that it smashes those things together with a / separating each of those directory names. So what would this look like in your R scripts? At the very top, you'll start by loading the libraries that you need, and then maybe after that, you're going to define the path to your home directory. So what I have here is a variable that's called home.path. I have the assignment operator saying that what comes on the right-hand side of that is going to be assigned to that variable. I then use the file path function. I put in as arguments the path to my documents folder. Later on in my script, I'm going to use the readRDS function, which is used to read RDS files. And then I'm going to use file path again. And as my first argument, I'm going to put in that home path variable, which is going to reference my home directory. And then after that, I put the actual file name that I'd like to load, which in this case is a file called collegeparkweather2017.rds. So what's happening with this? Again, the file path function is mashing together each of the arguments to form an actual path to a file. So this bit of code that I have here at the top, where I define home path to be the path to my home directory using the file path function, and then I mash those two things together inside the readRDS function to create the path to a file, is exactly the same as the code I have at the bottom, where I write out the full path to the file. Again, you can see why this is a lot easier, because at the top of my file, I define home path once, and it's a lot less typing, and I always know that that's going to point to my home directory. So all I have to do is add on the file name that I'd like to load for my home directory after that. But again, how does this make reproducibility easier? Suppose that I have this script and I give it to my evil twin. My evil twin's username is Tim Shara, but you really know he's my evil twin because he's using a Mac. So his home directory is in a completely different location. So what you see here is all he has to do is modify one line at the top of the script where the file path to the home directory, the home path, is defined, and change what I had in there for my home directory to his evil twin home directory. Everything else in the script can remain the same because now he's changed the path to his home directory. Again, this would be exactly the same as typing in the path to his home directory in every file reference, but here it only has to be done once. So again, this is a lot of extra typing. It seems like an extra step. You might wonder, am I just being pedantic? The fact is, a single R script will often load several different data files. It's probably going to save one or more output files, and it might perform other operations on files as well. You need to tell R the location of every one of these files, and so this is going to be a lot of work to change if you ever move data around on your computer or if you ever share the script with someone else. As something a little closer to home, I'm going to give you a lot of sample code in this class, and I will always use this convention. There'll be a line at the top that sets the directory to my home directory. It's not going to be your home directory's path, so you'd like to be able to change that. Because I set it at the top with a file path statement and save that in a variable, you'll only need to make that one change, and as long as you still have data in the right location, then the script should run without additional modifications. As an alternative, I'd like you to imagine searching through every script that I give you and updating paths in every location just so you can get a script that I've given you to run. Again, this is the essence of reproducibility. It makes it very easy for you to take my source data and my script and get the exact same results as me.